Okay, question 6, we have polynomials. So, f of x is equal to minus 3x cubed add 8x squared minus 9x add 10, where x is in the reals. A part 1 wants us to calculate f of 2. Okay, so f of x is minus 3x cubed add 8x squared minus 9x add 10. Okay, so f of 2 just means we substitute in x equals 2. So we're going to get minus 3 lots of 8, add 8 lot 4, minus 9 lot of 2, add 10. So that's going to be minus 24, add 32, minus 18, add 10. Now, quite happily, that is going to give us minus 24 minus 18 is minus 42. 32 add 10 is positive 42. So we get 0. Cool. Okay, then A part 2 wants us to write f of x as the product of two algebraic factors. So, if you haven't realised yet, this is fact theorem stuff. So, we can say that as f of 2 is equal to 0, then by the fact theorem, x minus 2 is a factor of f of x. So we know that f of x is cubic. So if we have a linear factor, that means there has to be a quadratic factor. So we could say f of x is equal to x minus 2 times ax squared add bx add c. Okay, now we need to find the values of a, b and c. So, we know that there's a minus 3x cubed. So, that means that a has to be minus 3. Now we also know the constant term at the end is 10. So that means that minus 2 times c has to equal 10, which tells us c is equal to minus 5. So up to there, we can say that f of x is x minus 2 times minus 3x squared add bx minus 5. So now we just need to find b. So what I'm going to do is get all the x terms that we would get from this expansion. So we would get minus 5x and we would get minus 2bx. Now we know that that has to be minus 9x. So if we divide through by x, minus 5 and, minus 2b is equal to minus 9. Now if we add 2b and add 9, we get 4 is 2b. So b is 2 and f of x is x minus 2 times minus 3x squared add 2x minus 5. Cool. Okay, then for part B, using the answer to A part 2, we want to prove that there are exactly 2 real solutions to the equation minus 3y to the 6 add 8y to the 4 minus 9y squared add 10 is equal to 0. And that's 2 marks. Okay, so before we worry about the y's, let's see how many solutions this guy has. So we know that if x minus 2 times minus 3x squared add 2x minus 5 is equal to 0, then x is at least 2. Now what we need to do is check whether this quadratic has any solutions or not. So let's find the discriminant. So A is minus 3, B is 2, C is minus 5. So B squared minus 4ac is going to be 4 minus 4 lots of minus 3, so that's positive 12 times minus 5, so that's going to give us minus 60, which gives us minus 56. So b squared minus 4ac is negative, which means no real roots for the quadratic. So that means the only real root of f of x is x equals 2. Okay, so for part B, let's see. So hopefully you notice we've got the same coefficients going on here, minus 3, 8, minus 9 and 10, as we do up here. So with the minus 9x, for example, we've now got minus 9y squared, So we're going to make the substitution x is equal to y squared. So let's just check that that works. So we got 8y to the power of 4. We did have 8x squared. If x is y squared, x squared is y squared squared, which is y to the power of 4. And if x is y squared, x cubed is indeed y to the power of 6. So it works. So if x is y squared, then x equals 2 means y squared is equal to 2. So y is equal to plus or minus root 2. Cool. Okay, then part C wants us to deduce the number of solutions for theta between 7 pi and 10 pi of the equation 3 tan cubed minus 8 tan squared and 9 tan minus 10 is equal to 0 for 1 mark. So this is the same equation as our main man from up here. The only difference is the signs have flipped, but we could move everything over to the right and we would end up with the same equation except x is tan theta. So for part C, we know we would get down to tan of theta is equal to 2. Now if we sketch tan in the interval we're in, so 7 pi up to 10 pi, well we know that tan is 0 at every value, at every multiple, of pi. So that would be 8 pi then we got 9 pi so that's what tan looks like between 7 pi and 10 pi. Now we want tan of theta to equal 2. So if we draw a line across, it's going to hit the curve once, twice, 3 times. So there are 3 solutions. Cool.